day, and welcome to this presentation about what is the future of data exchange in the lighting industry, BIM, and much more. This presentation will be split into three different presentations. The first one will be held by architect Roberto Corradini, who is a very famous Italian lighting designer, who will introduce the needs of the lighting designers and of the designers in the world in terms of data exchange and data needed for the lighting process. This presentation will be followed by my presentation about what is going on about the development of the new files for data interchange in the lighting sector. And the third presentation will be held by engineer Giampiero Bellomo, who is a very famous expert in Italy for the BIM sector. So I wish you a nice time with our presentations.
Thank you, Stefano, and thanks to all the attendants to my presentation. Talking about the lighting design industry, and especially my profession as lighting designer, there is sometimes a misunderstanding about what is or what does lighting design mean. Sometimes we think lighting design is just choosing a luminaire in a catalog, finding a beautiful shape, finding something with a beautiful finishing, build a 3D model, put all the luminaires in a row, or build a scheme of the luminaires, and then calculate how much lighting we can obtain on the floor or on the surface. Sometimes our softwares offer a visualization in false color that it's particularly useful, but it's not enough. The information we are able to obtain or to find in the web catalogs or in a website sometimes are limited only to just the photometrics. So when we choose a luminaire, we have the possibility to understand what kind of beam opening we have and possibly some other details about the intensity of the luminous intensity. And this allows us also to make some simple and rough calculation about how much light we can obtain on the task surface, just understanding and evaluating the distance from the luminaire to the surface. It's very simple. But if this is very simple when we work in a new architectural project or in something that is built from new, what about if we have to work in another situation? Let's make an example. Let's suppose we are hired to design the lighting for the interior dome of the Pantheon in Rome. We can build a concept, we can find the positions for some particular luminaires, and we can have an idea about the luminaires. If we choose a luminaire in a catalog, we can obtain some data that are absolutely interesting for understanding the power consumption, the luminous efficiency, of course, the optics, the adjustability, the dimension, also the weight. And then we have some data that are, let me say, not so much meaningful for us. For example, the color temperature and the CRI, but the numbers themselves are not meaningful for us as lighting designer. And also the photometric file that we are able to download from the company or the manufacturer website is not enough any longer, because we have just a quantity of light. We have just the information about quantities, not quality. For a project like the Pantheon, first of all, we have to consider that it's very difficult to build a 3D model that can simulate also the materials and the ancient surfaces that are part of the building, also the colors, also the, let me say, the finishing of the colors are very difficult to simulate in a 3D model. And so also the calculations are very difficult and cannot be precise. So, what do lighting designers need from their side? Well, let me say, the first thing I want to know is this entire spectrum of the light source, especially with LEDs, because LEDs were not created equal. I want to understand exactly what is the emission of the lighting source, and especially in the regions of blue and in the regions of violet, because of course LEDs doesn't emit UV, but not only UV, but also the quantity of light can damage some pigment and some color. I want to know the color parameters according to the most recent standards. In this example, the TM 30 2015. So I want to know the chromatic rendition index, not just based on 8 or 15 colors, but I want to see the 99 colors, because this information can be absolutely useful to understand exactly what kind of pigments are affected by the luminous source I am choosing. Then, most of the manufacturers state in their catalog their luminaires are just 2 or 3 step mechanisms, and the ellipses are sometimes very rough. This is not useful for us. I want to see a diagram with the nominal color temperature, correlated color temperature. I want to see exactly where the mechanisms ellipses are found, and especially in the part of the black body. I want also to know the radiant flux emitted for wavelength, because in some particular projects, for example, wineries or food shops or art galleries, etc., some wavelengths can be very dangerous or can create damages on pigments, flavors, and other peculiarities that are typical for bed products. To my knowledge, there are no manufacturers at this time that that are sharing this kind of information. But let's think we are choosing an RGB product. So, what is the emission for single channel? I want to see exactly the emission, because if I try to create a colored light, I want to see how I can mix the RGB emission and create that particular color. That sometimes is very difficult. And of course, I want to obtain the significant pixels of the luminaire, not just the finishing, but also the dimension, to understand if it's possible to put the luminaire in the position I recently considered. And I was to customize my data sheet in a way that is not just automatic because it was created by the manufacturer. And this not mean that I had to put my own logo on this paper. I want also to build my data sheet in a way I can choose exactly which information I would like to share with the contractor, with the installer, with the architect, etc., etc. So I have 3 questions for the manufacturers. May I find all the data I need included in a unique file, so I don't have to waste time looking for the data I need in different sources? So a unique file doesn't mean the photometric data, so a IES or Illuminate file is not enough. So another problem, may I automatically verify if the data I need are updated so I don't have to waste time calling the manufacturer, the sales agency, the representative, and ask if the data I found in a catalog that was printed 6, 8, 12 months ago are the same data that are currently offered to the market by the manufacturer. And the last question, I would like to save my data in my open and customizable database because I don't want to be forced to use a particular software or another kind of solution that is not useful for me. I want to create my own database and I want to store all the data I need in my database so I can use it when I want. So my last wish is I would like to automate the process and avoiding to look for data among several info sources like, for example, catalogs, website, email, email sending, or phone calls. This is my wish, and I hope also my colleague lighting designer will agree with me. Thank you very much for attending.
Okay, thank you very much, Roberto. So, what is the future of data exchange in the lighting industry? BIM and much more. As you know, BIM is the new methodology about designing. We should ask, is going to be BIM in the future of lighting design? As you know, BIM is a new way to approach the design from different point of view. It is not the simple way we used to design in the past. So the designer used any kind of CAD programs, and they used to draw some lines in order to describe the construction. It was not possible to have standardized information about the products. It was not possible to deal with circularity, which is the base of BIM. It was not possible to interact among different people participating to the same project. It was, in a way, yes, as a concept, it was possible to deal with different people, but all the process was not automatically managed by a system. So BIM is approaching the design process in this new way, in this new form. So let's say, what is BIM in the world? How is it, was it introduced by the different countries? So we can say that almost most of the countries all over the world have approached BIM in the past years. And it comes now that the BIM will be the new frontier when it comes to carrying out projects and managing works, mainly those regarding public sectors. Yes, because the approach was mostly based at the beginning on public works. But let's see what's going on about different countries all over the world. United Kingdom. As you know, United Kingdom is one of the most advanced countries about the BIM process introduction. So it was introduced in a way to be mandatory for public works and private sector works, and it was tested in a very efficient and positive way during the works about the Olympics back on 2012, when the Olympic Games were played in London. At the beginning, they started with public works, but it was automatic to switch them also to private works. In Italy, it is mandatory for the public sectors, and it is defined by a country law called the Rio Decree on January 12, 2017. This law is describing how to introduce the BIM in different steps, let's say from 2019, all the works with a total amount of money involved above 100 million euros, up to 2025, when all the public works below 1 million euros will be mandatory to manage through the BIM. In Spain, it is not mandatory, but its use is recommended in several documents. It is, in any case, mandatory in Catalonia, one of the regions of Spain. In France, it is going to be mandatory from the 1st of January to 2022, even here for public works. And at the end, in Russia, it is mandatory from the 1st of March, even here for public works. So you can see that step by step, BIM is going to be introduced all over the world. But what is the main characteristics about the BIM world? The BIM concerns all professionals involved: manufacturers, lighting designers, distributors, contractors, since they are able to exchange information in an interoperable way. So interoperability is the main characteristic of BIM. It means that we have to cooperate together. All the different parts must cooperate together in order to achieve the goal of the project. So interoperability is absolutely joint cooperation. Different lighting designer as well as other professionals involved cooperate by passing information among themselves through interoperable files. It was not in this way in the past. In the past, we used to work on drawings. There were meetings, but it was not possible to integrate the information in a very efficient way, in an electronic way, let's say. So this is what BIM is doing. And you can understand which is the great advantage that BIM is introducing, because the BIM is not only limited to a simple design process. It is much more, because as Autodesk defined through a very famous drawing that we're going to see later on, it is circularity. So not only we are limited to the design process, but we have also the maintenance included and manageable through the BIM. And the design process is much more limited than the maintenance process. And then how to recover the materials at the end of the life of the building, of the construction. So let's go back to understand more precisely what interoperable file means. I have to say that it was very well defined by the Italian law on BIM. This law, at the article number 4, says that all the files must be regulated. They have to be open, digital formats, and non-proprietary. And they have to be managed at national or international level and controlled in their technical evolution by independent organization. This is the key point. The files must be managed by independent organization. It means that, just to give you an example, more and more now, we see that the BIM world is managed through, for example, RFA files, that they are the most famous files involved in the BIM process. But the RFA files are not BIM files. That cannot absolutely be considered BIM files. They are proprietary files because they are belonging to Autodesk. So there is the need to find a new file that can have all these characteristics. And we can say that in order to understand what is the world of BIM about the products? We have to say that the BIM is involving not only luminaires, it is involving only even ceramics, it is involving bricks, doors, chairs, tables, anything, windows, anything that it can be related to the world of construction. So if we consider that this circle as the whole circle about the products involved in the BIM process, we can say that lighting products are very limited. Probably it is less than 0.503% of the all products involved in the BIM process, in the construction process. So we have to ask ourselves, can the lighting sector influence and direct the other sectors? This is the key question. And we can answer that it is absolutely impossible that lighting can influence all the others. So we have to follow the lines described by the BIM. As of today, we can say that there is no standardized BIM file for the lighting industry. We were on the process to define this file, but it was not possible, and we'll see why in a few seconds. But we have to say that there is a file that has all the characteristics corresponding to what the interoperability is asking us. And this file is the IFC. The IFC is a structured file that can be configured for any product family, product type. So for example, for the ceramics, we can use the same structure, but the information included at the file will be related to ceramic. For a lighting product, we have the same structure, but the information included will be related to a lighting product. So it means that in this case, we will include the photometry, we will include the spectrum, we will include all the information related to a lighting product. And the IFC structure is capable of corresponding, as we said, completely the requirements of the BIM world. This file is managed by an international and independent organization called Building Smart. So, what's going on about the structure? Let's get into more details about the structure of a BIM file for lighting. So, a BIM file is always characterized by the characteristic data. This is the first set of the three large data sets that a BIM file is based on. Then we have performance data, it's clear, photometry and spectrum. Then we have further data, like the 3D level based files. It means that we can include different levels of development. So it means that for the starting process, design process, we can use a 3D, which is very simple. We can consider it the bounding box. And then step by step, whenever you define in a more precisely way the project, then you can use a 3D file more defined, up to come at the end to the real 3D file about the luminaire. Then we may include pictures, we may include other information that are accessory information in order to complete the information about a product. So you can understand that it's something completely different from the approach that we had up to now when we use the ULUMDAT or the ISLM63 files. Those files are very limited and are forcing all the designers, like Roberto said a few minutes ago, they are forcing the designers to go around and search the information, which is absolutely, we are on 2021 and almost on 2022. And we are really letting the designers work in a very prehistorical way. So, about the characteristic data, a big work was carried out by the European standardization body, which introduced the EN 17623 on 2021. BIM properties for lighting, luminaries, and sensing devices. Why? Because there was a huge need to define in a unified way the main characteristics, the main parameters of a product. For example, if we consider now two files about two products coming from two different manufacturers, and the information saved into an RFA file, and you ask them to designer to analyze those files, one of the main points that the designer will point you will be, listen, you have to consider that one manufacturer is defining power as power. The other one is defining the same parameter in a different way. So it is defined as total power. So you can understand that for a designer, this is a pain in the ass. So it is really a very big problem, because it is difficult at the end, if you have many products, to compare them and to analyze the information in the proper way. So this standard is helping us to define clearly the different parameters in the same way. Then what about performance data? We are now having a great development in different ways, always about lighting. For example, up to now, we ran all our projects considering only a light without color, because whenever you use a ULUM data or an IS file, you do not have the color of light directly managed, for example, by the programs. You calculate and the lighting will be always with the same color, but in reality, this is not the case. So with all that it is coming, all what is coming on about the development of the, for example, human-centric lighting and other issues like this, you have to always more and more manage spectrum together with the photometry. And so it is necessary to have more powerful files, and those files were defined recently by the IS through the IS XML, which is ISTM 33 on 2018, and UNI 11733 on 2019. These files are coming from the common cooperation in between IS and UNI. So it means that those files are exactly the same for the first 5 parts. But then it was brought on a new idea. The 6th part is in case a country is willing to include some information, some parameters about local laws, it will be possible. And this is what the Italians did with the introduction of the law about public lighting, which is a mandatory law over here in Italy. And this file, it is the file recognized by the Ministry of Public Works of Italy. These files are much more powerful than the old LDT and IS and M63 files that we have been using up to now. But it was clear that, as you can see here, we have that the LDT IS files are very, very limited, only photometry, in order to summarize what we said up to now. And these files do not only, the new ones, do not only consider photometry and spectra, but also laboratory data. So for example, whenever you use a ULUM files, you do not know which was the goniophotometer used. You do not know which was the set of instruments used for the design. You do not know the uncertainties. You do not know, for example, if which is the current. Because, for example, this is another pain in the ass of these manufacturers and designers, because now almost all the luminaires can be driven through the current. But if you have 10 currents, now you have 10 ulim.5s. Why? It is not necessary. It is possible now with the technology to save all the information at the single file. And these files have the structure, have the potentiality to include all the needed information in a single file, like Roberto said a few minutes ago. The designers need to have their work more automatic and their work more efficient. And so these files are corresponding also to their needs. It was clear that once we finished the work on ISXML and UNI XML, it was necessary to have a file that could be used all over the world. So coming from the experience of these two groups, we decided to bring the experience to the CIE in order to develop the CIE XML file. So as you know, CIE is a body, an international body, and there are different experts coming from all over the world participating to defining the standards, the recommendation for the entire world. It's sort of meetings of different peoples. They discuss, they define at the end a common way and a common document for the entire world. But something happened. So a question was proposed after a few meetings at CIE. Some members of the committee asked, why create a new CIE XML file when a new file, such as the GLDF file, is being currently developed? The GLDF file is the file proposed by DIL and by Relux as a new file for the future. But this file was proposed by private entities, by private companies. So we can say that it is no longer a technical matter. This question is proposing a political matter. It means that we have to ask ourselves if it is acceptable that a file developed by private companies without the approval of an independent international regulatory organization become a recommendation standard for everyone. This is a question that we have to solve, because otherwise, and this is in practice what happened, otherwise the development of this new recommendation will be blocked, because up to now the Commission was freezed and waiting for news about future developments. So this is where we are now. Where to go? It is the question that we have to solve as soon as possible. Otherwise, the world of lighting will not be in the world of BIM. Thank you. So now we pass to the presentation of the engineer Bellomo. Unfortunately, the engineer Bellomo today is sick, so he asked me to propose you his presentation. So, light beam. First of all, who is Engineer Bellomo? Engineer Bellomo is the most famous expert for lighting and beam in Italy. He is a member of many commissions over here in Italy at UNI, and also he is member of other commissions at CIE, at CEN, the European Standardization Body, and other ISO commissions. He is really a great expert about lighting and BIM for lighting. So Can all generated models be considered as BIM ones? So we can say that point clouds, they are not considerable as BIM file. Lines and curves, the same. From surfaces, the same. From solids, the same. These are not part of the BIM concept, but mostly they're part of the old CAD process, CAD approach. So the BIM model is a smart information container and should include all information regarding the construction and its parts. The BIM project describes the built environment, so we can include the 3D model. We can include the coded and discipline-specific information. We can include the relationship and hierarchies and constraints between components. Yes, because one of the key points about designing is that if the electrical engineer works on a construction, works on a project, he has to know if it is possible to let the cable pass through a wall. And so you have to define the constraints between and among the different components. The BIM project contains the geographical location, the description of the geometry, the material properties, the component properties, the system properties, the properties of the technical elements, the stages of implementation. So step by step, you define from the basic idea, you define the first step, which is the first approach to the design. And then step by step, you define more and more the projects and the definition of the different elements and components up to the final stage. Maintenance operation. This is a key point because up to now, and in many cases, it is quite impossible to know where the tubes are, where the cables are. And so it is costing a huge amount of money in many cases because without defining where the cables and where the tubes are, then you have to search them, and it is costing money. And of the cycle disposal. Yes, this is another key point because we know that a building, as any product, has a life. And at the end, having the full details of the components, it is possible to define how to get them back and reuse the different components for new products. And this is possible through the BIM world. So this is the drawing describing exactly what the BIM is. What the BIM is. So we launch the project, we define the draft, we define the form, we define the time, we define the cost, we define sustainability and the management. These are different steps that it is involved in the BIM process. So it is no more like it was done in the past through CAD programs. You can understand that the CAD is probably one little part of the whole process, but it is something much more than before, and all managed in the interoperable way. So the knowledge management, what does it mean? It means that if we define a building through the BIM process, we can have a structure and we can have all the information packed at a database. And from there, we can get back all the information in order to have the details about the products at any stage, at the beginning during the design process, but also when the maintenance is needed or when you have to get back the materials at the end of life of the building. So it is really, and probably the most perfect comparison in between BIM and something else is Lego. Lego is really describing the BIM process. So a team of people working together in order to get the final object, the final construction. Each item should incorporate all the actual product data. BIM objects should be parametric as much as possible. This is another key point. All objectives and objects must be considered, otherwise the model is incomplete, and with it, all the resulting data. It should be interchangeable between different software, and this is another big point. So interoperability, up to now, we dealt only with interoperability about the data interchange files for products. But interoperability, it is also the interoperability of the project file in between different applications. So it means that I am an electrical engineer, I use a certain program, and I work on the project. I input all the information and details about the electrical staff, and then I pass the project to another engineer dealing with tubes, dealing with, I don't know, civic works. And they have to, and they work with a different program. Interoperability means that the same project file can be used by different applications. And I have to say that this is not yet at the point. It means that we have many problems because it is difficult to have the old programs having the same functions. But the Open BIM, which is an organization trying to define a common project file standard, is working in this direction in order to let the people interchange a project file through different applications. So, from the old world, in order to synthesize what was previously, we had a work where the different people managing the design process were interacting independently from the others. So it was only 1-to-1. It was not like in the BIM that we work in a common on a common file that is shared by the different people that can act on the file at the same time. In this case, it was in a way we have the electrical engineers. The electrical engineers used to talk to the civil engineers that then has to talk to the other engineers or to the installer, etc. It was more messy in this way than what can be through the BIM approach. Building Smart is helping, as we already said, in defining the standards in order to share the information in a more and more efficient way than before. Some benefits. We already defined them. Graphic models and other models, graphic and elaborate models, models and regulation standards. So, for example, it is through the BIM also possible behind the definition of the constraints in between different products part of the project, we can also through the BIM define if the use of a product is corresponding to a standard or not. You can understand that it is another key point because up to now we have to manually read the information, and it is not managed automatically. With the BIM, it is possible to have the class detection. It is possible to have the model and code checking. So all features that can be managed in an automatic way. And at the end, other advantages, other benefits are the bill of quantities. Automatically, we have the quantities of the old products used by the different designers. have at the same time technical specification without going around through the websites of the manufacturers in order to find the technical specifications. Have the construction phases managed with times and costs, and maintenance operation like we already defined. So it is really a great revolution. And if we work in the open BIM way, we can really think that different people developing different parts, even different software, can cooperate together to get a common goal, which is the construction project. And you can understand that at this stage, for example, we have also some other facilities about the maintenance, for example. In this case, this image is saying to us that it is already now possible to manage the 3D reality. So it means that we can use a special, let's say, camera, a special object that can help us to see and to get into the different areas of my project and analyze what is going on, and define immediately what is the approach that we have to use to solve at the end the problem. So you can understand from what we said up to now that really the BIM is helping us in different ways to integrate the different operations that and different managements that up to now were kept separately and managed separately. We can have them managed all together through a single project file. So about the standardization, the ISO published the ISO 19650 on 2019, and it is describing the BIM words. So it is based on the 3 parts. The first part is about the concept and principles. The second one is delivery phase and real estate. And the third one is the management phase of real estate assets. And another standard is defining the IFC open scheme. And there are other standards about the different issues like delivery manuals and the IFD, the IDM, and the IFD about classification. From this standard, main standard, is coming another standard that is ISO 16739, and for the definition of the industry foundation classes about the IFC that we see here. And from here, it was driven the definition of some standards, for example, over here in Italy. So it means that there is a huge process going about the definition of the BIM world all over the world. You can see here about Italy, about UK, about Germany, about France. If we can, if we had some comments, we would say that probably the process should be defined and managed more commonly. As you can see here, any different nation, any different country is managing the standardization at the end by their own, and they are not always integrated. What is it carrying on? It is carrying on more or less a problem about interoperability, because you can understand that if we have different standards in different parts of the world, then it could be more difficult to manage the products and information about the products in the same way. So the checking of the products is more complex than having a single standard in common for everybody. But at the end, we can see that the process is ongoing. In Italy, so we already dealt with this standard that it is defining the different properties. So this standard, sorry, not only in Italy, it is a European standard, which is based on different chapters. And so at any chapter is managed a set of parameters. So for example, ID 01 is for mechanical parameters, then we have electrical parameters, emergency lighting parameters, photometric, table 4, and it is previewed that the connection, this part is connected to these files. So it means that it is possible to link these files to the set of information, to the other set of information. Then we have ID 05, so table 5 about the sensors and detection devices, then assembling and accessories, then marketing information and management and maintenance information. You can understand that this is really a great standard because it is really synthesizing all the information in a proper and ordered way, which was something that was absolutely needed. And this is the part describing the information, the photometric and spectrometric information managed through the IS TM33 and UNI 11733 files. So even about a few words about the levels of details. I have already mentioned you that it is possible to split the project into different phases. So whenever you start with the LOD, level of development A, and then you go on up to the end level of development. It means the level where you include at your project the final 3D of the different products. So you start, just to synthesize this concept, you start with a bounding box of the luminaire of the object of the product you want to use, and you end the process with a complete 3D product file, which is synthesized over here. We have to say that the level of development was a concept that it is still used, but it was modified and it was put together with the LOAN, which is the acronym of levels of information needed. So it means that it was quite complex to manage only the LOD because it was too fixed. It was not flexible. So with the level of information needed, you can come out of the concept of LOD and use this new concept because you may need to use a more defined level of definition of your product at a certain point of the project, not only at the end. So for example, if you need to define the constraints in your project, then you cannot wait up to the end because otherwise the other cannot go on with their work. So you may need at that time to use the real 3D of your product in order to check all the constraints. And probably you are at the middle of the development, project development phase. So the LOIN is really helping, this new concept is really helping in order to have a more flexible way to approach the process, the project. And this is what the Italian regulatory system is defining. So the different parts of this standard, that it is digital management of construction information process BIM, and all the parts characterizing this standard, always in the line of the BIM concept. So in here, we have some examples about the process. It was studied through this machine, through this system, and realized the 3D of this object. Then it was the products were headed to this design in order to come at the end to the final lighting. And this was managed obviously through the BIM. And at the end, we had the chance to have all the list of materials, all the power consumption, all the maintenance needs perfectly defined through a single project file. So there are different programs managed, and these programs were also managed for the construction of the new stadium of Atalanta over here in Italy. And the BIM process was used with great satisfaction for everybody, because the BIM process involved the engineering, the architect for the designing of the cover of the tribunes, the MEP, the structural, the project management, the construction manager, the facility manager, and the builder, all together working on the same project. And these are some examples about this stadium. And the BIM was very useful because, for example, it had to define the constraints. Because when was defined the 3D of the stadium and about the new cover, it was clear that having to install the luminaires over here, it was absolutely needed to define if there could be placed exactly where in the design was defined. So it means that without the BIM, it was not possible to see that it was not possible to install the luminaire over here, and it has to be moved. And it was done through the project phase, and not once the installation was on the way to be done, and find at the end that it was not possible to place the luminaire exactly here. So really, the BIM approach had to go there and install the luminaire exactly where they could be installed. A few words about the programs. So there may be different approaches. It is clear that it is not possible to have a program, let's say a BIM editor, working on a project, and at this BIM editor could had all the features about, for example, the lighting calculations, about the calculations on the structures, on the different platforms, resistances, whatsoever. So it is clear that more and more we have to define a world where different programs cooperate together in order to transfer the information. So for example, we may consider a 3D and a program that is fully dedicated to lighting, for example. And this can be done through technical software or through technical applications, through technical apps. And this Piero Bellomo is coming to say exactly what we already mentioned before, that the lighting sector is really a very little sector compared to all the others. So really, we have to focus on the definition of a new IFC file that can be then used by different programs and used by different manufacturers to store their information. It is not suggestible to develop other files, because other files are taking time, for example, to the manufacturers, because they have to create other files. Let's focus on a single file that the people in the market, the designers in the market can easily use and use at the same level. So let's say that we can have an IFC file for ceramics, and when I have to define the floor of my room, I have a file, an IFC file, so that when I have to define the lighting, I have an IFC file for the lighting, and the process will be managed always in the same way. Let's not think about something different. So this is summarizing exactly what we did. It is absolutely possible to use an IFC file and to then manage databases. Because if you structure your database in order to let the information be included, imported at your database, if we have different files, then we have to develop different applications in order to manage them. And we have to say that, for example, over here in Europe, it's on the process about the definition of a product, big product database for everybody. And if we do not define, as we said before, a common standard, it will be difficult to supply the information to this database. We have to focus on a single file. And this is to summarize the concept that we have to consider the standards, the more advanced standards, and consider that the old LDT and IS files cannot be anymore used in future. We have to pass through more powerful file like the IS file and the UNI file. Thank you for participating today to this webinar, and we hope to have let you some ideas to think about. Thank you again, and I wish you to have you again on one of our next webinar.